All right, these are example problems from the study island topic. Use and interpret line of best fit. Number one, the scatter plot and line of best fit show the relationship between the number of candy pieces that students ate and their scores on a quiz. So let's take a look at the data points there and take a look at the line of best fit here. Whenever you look at a line of best fit, you should look for two things: the y-intercept and the slope. The y-intercept of this line, and that's where the line crosses the y-axis when x is 0. Okay, so whenever it crosses the y-axis, the x is 0. The x is always 0 on the y-axis. So the value that y is when x is 0 is 80. It looks like it goes right through the point 0, 80. Now the y-axis is measuring a quiz score, 80, and the x-axis is measuring candy pieces, 0. So the y-axis tells us in this particular case that 0 candy pieces corresponds to a quiz score of 80. So the y-intercept is 80. Now we try and find the slope. What's the next grade point that the line goes through besides 0, 80? Well, if I go down one space and then over 3 spaces, it goes through another grid point. Now this grid point is 15, 70. That's 15 for the x-coordinate, candy pieces, and 70 for the y-coordinate, quiz score. So this point represents 15 candy pieces and a quiz score of 70. I can double check that that was a good slope, going down 1 and over 3 by going down 1 and over 3 again. And sure enough, I end up at another grid point and down 1 and over 3 again. So the slope of the line of best fit will tell us a lot of information. If we go down one space, that corresponds with a decrease of 10 points for a quiz score, because every space here is worth 10 points. If while I go down one space, I go over 3 spaces on the x-axis to the right, that corresponds to an increase of 15 candy pieces, because each space is worth 5 candy pieces. So if you go over 3 of them, that's 3 times 5, just 15. So going down 10 points in a quiz score corresponds with 15 candy pieces more being eaten. Right here, if I go down another 10 points and over another 15 candy pieces to 30 candy pieces, we have another point, and then another 30 candy pieces corresponds with another decrease in 10 points of quiz score. So now we can answer our question: which statement describes the relationship between the number of candy pieces that the students ate and their scores on the quiz? A, an increase of 15 pieces of candy eaten produce a decrease of 10 points in their score. That is it. That's the right answer. As we grow 15 on the x-axis, that is an increase of 15 pieces of candy. And every time we do that, we lose 10 points of quiz score. So that's a decrease of 10 points in quiz score. You should make sure you know why the other sentences are wrong. B says an increase of 15 pieces of candy produces an increase of 10 points in their score. That would mean their score is going up as they ate more candy, but that's not what's going on here. They are losing points. C says an increase of 15 pieces of candy eaten produced a decrease of 15 points in their score, but their score is not going down by 15 points. It's going down 10 points at a time. And same thing with D. It says it's an increase. Again, it's definitely not an increase. And it says 20 points. So that's way off. So A is the right answer there. Number 2. Each week that the band participated in a school fundraiser selling hot dogs, the treasurer created a scatter plot of the cumulative amount of money they were able to raise by the end of the day. Below is the scatter plot for the third week. So you've got fundraiser. On the x-axis, we have the days: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and money raised. What does the y-intercept of the line of best fit mean on this graph? So the line of best fit here intersects the y-axis at 150. So the money raised is 150, but that's before the week even starts. Notice the first day of the week here is Monday, then Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So the 7 days of the week are already included right here. They had 150 before any of that happened. So let's read through our choices. School was not in session on Monday. Saturday was a much better day than Tuesday to sell hot dogs. The band had a slow week. Or the band started the week out with $150. There it is. They had $150 before the week even got going. So that's why the intersection of the y-axis is at 150. Number 3, use the given line of best fit to approximate the rate of change relative to the scatter plot below. The rate of change is the slope of the line. So I told you should look for the y-intercept and the slope of the line. This one is basically just asking you for the slope of the line. You should know how to find the slope of a line. Find 2 points that the line goes through, and then calculate the slope by checking how far it goes up or down, and divide that by how far it goes over right or left. So this is going to be a negative slope since we read it from left to right, and it goes down as it goes left to right. Any line that goes down from left to right is a negative slope. When I look at our 4 choices, they are all negative. So that's a good place to start. Now, this is a difficult slope to identify because it's really difficult to find exact points that the line goes through. Maybe it's because the graphic is just not that well made, or maybe it's because they just want us to get the best answer, the closest answer. Either way, let's do the best job that we can on finding 2 grid points that the line goes through. Now, the only one that it looks like it really goes through for certain is all the way down here at the end. It looks like it goes right through this point, which is the point 9, 2. That's candy consumption 9 and quiz scores 2. I don't know what this program has an obsession for candy consumption and quiz scores, but that's that point right there. So 9, 2. If I follow that back and try and find another lattice point that this line goes through, this one looks pretty close. Let's say that is a perfect point that the line goes through. What would the slope of this line be? To get from this point to this point, what is the slope? To calculate your slope, you should calculate the vertical distance, 1, 2, 3, and that's -3 because I went down, and then the horizontal distance, 1, 2, 3, 4, and then make a fraction out of them. So that's -3 over +4, which turns into -3/4. Now, to make sure that that's good, I'm going to do another increment of that slope. I'm going to use that slope again to see if it goes to another point. So if I could go down 3 and right 4 to get from one point to another, I should be able to work backwards and go left 4, 1, 2, 3, 4, and up 3, 1, 2, 3. Now, like I said earlier, that doesn't look quite right. It looks a little bit off, but you can see -3/4 is very, very close here, and it might be the best option we have. If we look at our other possible slopes, they're going to give us an even greater difference, it looks like. Let's try them out. -1/2. If I'm from right here and I'm going -1/2, that's over 2 up 1, over 2 up 1, over 2 up 1. That is getting farther and farther away, as you can see from the actual line. So A is definitely not the answer. -3/4 doesn't look quite right either. -1, 2, 3, 4 up 3, over 1, 2, 3, 4 up 3. You can see it's just a little bit off. Let's try -9/10. That's over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're off our graph at this point. And then up 9, which would be all the way to 11. So that definitely doesn't look right either, even though we can't see it on the grid. And -3/5. Over 1, 2, 3, 4, 5, up 1, 2, 3. That doesn't look good either. So while none of these look perfect, -3/4 is the best thing we can do for this particular diagram. Number 4, the graph below shows a line of best fit for data collected from a group of college students on the number of hours of television they watch and the number of hours of sleep they get. So we've got our line here. The equation for the line of best fit is shown below. So it straight up tells us this is the equation of the line. Now, this is slope-intercept form, so remind yourself that slope-intercept form is y equals m times x plus b, where m is slope and b is y-intercept. So this equation is telling us that the y-intercept is 8, and sure enough, it goes through 8 right there. And it's telling us the slope is -2/3. And sure enough, every time we go down 2 and over 3, we end up at a new point on our line. Down 2, over 3, down 2, over 3. So our slope is -2/3 and the y-intercept is 8. Now, keep in mind what those correspond to. 8 on the y-axis is hours of sleep, and 0 on the x-axis, where that point would be, is hours of TV. So it's telling you that somebody that watches 0 hours of TV normally gets 8 hours of sleep. Then, for every 2 hours of sleep you lose, that's 3 hours of TV watched. So when you watch 3 hours of TV, you lose 2 hours of sleep, according to this particular diagram. Let's go ahead and read our problem. Based on the line of best fit, if a student watches television for 9 hours, how many hours of sleep would they be expected to get? All we have to do to answer this question is go to 9 hours of TV on our chart and see where the line goes through that 9-hour mark. The line goes through the 9-hour mark right there. And if we follow that over to the y-axis, we see that's 2 hours of sleep. So according to this, someone who watches 9 hours of sleep is expected to get 2 hours of sleep. So I think I just said that backwards. Somebody who gets 9 hours of television watching in gets 2 hours of sleep. So someone who watches TV for 9 hours gets 2 hours of sleep. Number 5, the graph below shows a line of best fit for data collected on the number of flower arrangements remaining in storage at a florist's in relation to the day of the month. So we've got a line going down here. Again, this is a negative sloping line. Let's go ahead and just jump right into the question. The equation of the line of best fit is shown below. Again, we have a slope, negative 25 thirds, and a y-intercept of 250. So when the day of the month is 0, so when you start the month, there are 250 arrangements remaining. So the day of the month, on the 0 day of the month, that means right when the month starts. There's been 0 days of the month so far. 250 as a y-intercept means that the flower or the florist starts with 250 arrangements. Then a slope of negative 25 thirds means that as 3 days goes by, the number of floral arrangements available goes down by 25. Go down 25 and over 3. Down 25 over 3. So every time you decrease the number of arrangements by 25, you're increasing the number of days by 3. So as 3 days go by, 25 arrangements are sold or lost. What does the y-intercept represent? We just said it. 250 is the number of flower arrangements available right when the month starts. Let's see which one says that. A, the number of arrangements left in storage at the end of the month? No. B, the number of arrangements in storage before the beginning of the month? C says the number of arrangements created during the month, and D says the number of arrangements sold per day. Definitely B, the number of arrangements in storage before the month even starts. Number 6, the graph below shows a scatter plot of an athlete's swimming record relating distance covered in yards to time elapsed in seconds. A line of best fit has been drawn within the data. So here we go. Again, line of best fit. The equation of the line of best fit is below. It says right here, y equals 4/3 times x plus 5. That tells us that the slope is 4/3 and the y-intercept is 5. What does that mean? The y-intercept is 5 means that the distance in yards when the time in seconds is 0 is 5. Now that's a little weird. How do you get 5 yards in when the time in seconds is 0? That's just an anomaly of the data when you start off a little slower than the rest of the traveling time. So you're obviously not 5 yards in before the time even starts, but that's kind of what this line is saying. The slope of 4/3 means that as the distance in yards goes up by 4, the time in seconds goes over by 3. So an increase of 3 seconds in time corresponds with an increase of 4 yards. So as you go forward 4 yards, time increases by 3 seconds. That's what 4/3 is saying. Remember, the numerator corresponds to the y-axis, and the denominator of the slope corresponds to the x-axis. If it's positive, that means they're both going up at the same time. And if it's negative, that means one's going up while the other's going down. Since both of these are positive, it's a positive slope. An increase of 4 on the y-axis, that's yards, corresponds to an increase of 3 on the x-axis, that's seconds. Let's read the question. Based on the line of best fit, how much time does it take to cover a distance of 85 yards? All we have to do is find 85 yards on our y-axis. We go up here, we find 85, and we go right on over to where it intersects the line. Now, obviously, that's a problem here because 85 yards is not on our graph. We have run out of space. So instead of using the actual physical line on the graph, we're going to have to plug the number 85 into the equation and solve. Again, the yards is the y-axis. So if we're trying to find what x is, that's seconds, when the yards is 85, all we have to do is plug in 85 for y in the equation and solve for x. And here's what that looks like. Okay, so I've got the equation written down. Y equals 4/3 times x plus 5. Again, it's asking about 85 yards. The y-axis represents yards. So if it tells us 85 yards, we can replace the y variable with 85. So I'll rewrite the equation with an 85 where the y is. So now 85 equals 4/3 times x plus 5. Solving this equation for x will tell us how many seconds corresponds with 85 yards. Subtract 5 from both sides. 85 minus 5 is 80. So 80 equals 4/3 times x. Now I have to solve for x. And like any other time you have a number times x, you divide by that number, called the coefficient, in order to solve for x if that's all you have left. So I want to divide by 4/3. Now you should have learned at some point that if you want to divide by a fraction, you have to multiply by the reciprocal of that fraction. So I want to divide by 4/3 here in order to get rid of the 4/3. And I'm going to do that by multiplying by 3/4. The reciprocal of a fraction is that fraction flipped over. So if I multiply 4/3 x times 3/4, multiplying 4/3 times 3/4 eliminates the coefficient 4/3 because 4/3 times its reciprocal is 1, so you have just 1x. Of course, if you divide one side by 4/3, which we did by multiplying by 3/4, you have to do it to the other side. So the other side of this equation needs to be multiplied by 3/4 as well. Now I will treat the 80 as 80 over 1. 80 divided by 4 is 20, and 4 divided by 4 is 1. 3 times 20 is 60, so 60 is equal to x. 3/4 of 80 is 60, so that's x. When I go back to my problem, I can find 60 as the answer for x by looking through the options, and there it is, C. Number 7, the graph below shows a line of best fit for data collected on the average heights of children. So here's our line. Let's jump right into the question. The equation shows the line of best fit is below. The equation for the line of best fit is shown below. Based on the line of best fit, what is the expected height of a 6-year-old child? Well, we have to find a 6-year-old child. The age in years is on the x-axis, and we can find 6 on the graph this time. As we follow 6 up, we can see it's just about 40, not quite, but definitely closer to 40 than 45. So those correspond with inches. So we're looking for about 40, 41 inches. When I get to the options, 41 is there. That's clearly the best answer. No more work necessary. Now, if I wanted to plug in the values like we did on the last problem, the age, what they gave us, was the x value this time. So it'd be 10/3 times x, but our x would be 6. So 10/3 times 6 plus 21. 10/3 times 6 is 60 divided by 3. And 60 divided by 3 plus 21 gets you 41 because 60 divided by 3 is 20, and 20 plus 21 is 41. Number 8, Gilded Gifts Company hires employees to make handmade greeting cards. The manager is determining how the time spent training new employees affects their production of greeting cards. The scatter plot below shows how many greeting cards each employee made the past month and the number of hours of training the employee received. A line of best fit is drawn. So there's your data, there's your line of best fit. Let's get right into the questions. Complete the statements based on the scatter plot. The slope of the line of best fit is what? Now, back up in the beginning, it has instructions for how you should fill out those boxes. It says to use numerals and to use a slash for a fraction. So we're going to find our slope as a fraction, and we'll use the slash as our indicator of the fraction bar. What's the slope of this line? Find some lattice points that it goes through, and then evaluate. Right in the beginning, it looks like the y-intercept here is 100. The next lattice point it looks like it goes through is right here. That's the slope of going up one space and over two spaces. What were the actual distances traveled in that according to our graph? Well, those two horizontal spaces were worth 5 hours of training, and that increment of one vertical space was worth 25 greeting cards. You could tell because two spaces is worth 50 greeting cards, so one space has to be worth half as much, that's 25. So the slope of this line is an increase of 25 greeting cards as the hours of training increase by 5 hours. We can follow that to make sure we're accurate. Another 25 greeting cards. There's another 5 hours, another 25 greeting cards, another 5 hours. If you divide 25 greeting cards by 5 hours, you get your slope. 20 divided by 5 is 5, so that's 5 greeting cards per hour. So we're going to go ahead and type in 5 into that first option. The slope of the line of best fit is 5. Next, this means that for every additional hour of training, 5 more greeting cards are expected to be made per month. Without any training, an employee is expected to make how many greeting cards per month? Well, without any training is 0 hours of training. So what does 0 hours of training correspond to? It corresponds to 100 greeting cards. So we can fill in 100 in this box. Next, if an employee has 70 hours of training, the employee is expected to make blank greeting cards per month. All we have to do is follow 70 hours of training up to the line of best fit, but 70 hours of training is not on our graph. So what we're going to have to do is find out what the equation of this line is, and then plug in 70 hours into that equation. Writing an equation for this line is easy because we just identified the slope and the y-intercept. All we have to do is remember that every line can be modeled with y equals m times x plus b, where m is the slope and b is the y-intercept. Once we have the slope and y-intercept, we can plug them into the formula and we have our equation. In this case, we found that the slope was 5 greeting cards per hour. So m equals 5. The y-intercept, which is what y was when x was 0, we just said was 100. That was an employee making 100 greeting cards when they had 0 hours of training. So the y-intercept, or the b, is 100. Therefore, the equation of this line is y equals 5 times x plus 100. Now that we have that equation, we can plug in 70 hours of training. Now remember, the x in this equation represents the hours of training, and we know that because the hours were marked on the x-axis, and the y variable represents the number of greeting cards. So if we want to know the number of greeting cards that correspond to 70 hours of training, we just plug in 70 for the hours variable, which is x, and it looks like this. Y equals 5 times 70 plus 100. 5 times 70 is 350. So 350 plus 100. So y equals 450. So 70 hours of training should correspond to 450 greeting cards per month. Number 9. A lifeguard at a lake recorded the daily high temperature in degrees and the average number of visitors at the lake. A graph of the data is provided. So there's our graph, there's our line of best fit. Let's answer the questions. Based on the line of best fit, complete the given statements. First statement, the expected number of visitors when the temperature is 82 degrees Fahrenheit would be about blank visitors. So all we have to do to get the answer to that question is follow our line of best fit through 82 degrees. Now here's 80 degrees, here's 84 degrees, so 82 degrees is obviously right between them. If I find where the line intersects that mark, 82 degrees, I see over 150 visitors on the y-axis. So 150 visitors corresponds to 82 degrees. Again, 82 degrees down here because the x-axis is measuring degrees. So 150, there it is. Next, if there were 525 visitors, the temperature is expected to be about what? Well, we're doing the same thing we just did, except we're finding 525 visitors on the y-axis rather than finding 82 degrees Fahrenheit on the x-axis. So where's 525 visitors? Visitors is on the y-axis. We look for 525. Well, we go from 150 to 300 to 450 to 600. Clearly 525 is in between those two. Exactly where? Exactly halfway, because these are 150 apart. 450 plus 75 gets us 525, and another 75 gets us to 600. So every one little space on this y-axis is worth 75 visitors. So 525 is exactly halfway between 450 and 600. If I follow that over, I see it crosses the line right there, which is right about 94 degrees. Maybe a touch below it would be 525. So we're looking at about 94, very close to it. And we look on here, we see 94, 96, and 92. Well, 92 is right here, and that's not at 525 yet. 96 is way up here, and that's about 600 visitors. 89 degrees is way down here. So 94 is clearly the best answer to this problem. Next, for every 1 degree increase in temperature, there should be about blank more visitors at the lake. Now, a 1 degree increase in temperature is moving 1 degree over on the x-axis. When you find your slope, what you're finding is how the y value changes as the x value increases by 1. So all we have to do to find that is we can take 2 points that we just found and we can find the slope. Here's how we do that. We just identified these 2 points as part of the line. 82, 150, because when x was 82 degrees Fahrenheit, y was 150 visitors, and 94, 525, because when x was 94 degrees Fahrenheit, there were 525 visitors. The way that we find the slope is we simply take how the y value changes from one point to another and divide it by how the x value changes from one point to another. The y value changes from going from 150 to 525 by 375. The way you get that is you simply subtract 525 minus 150. When you do that, you get 375. The x value changes over that same period of time by 8 because it went up from, 12. It went up from 82 to 94. That's an increase of 12. And just like we did for the y values, we can get those by simply subtracting 94 minus 82. Now, you don't have to do those in your head. You can use the calculator, and you should, in order to make sure that you don't make a mistake. There, I've got my calculator pulled up. 525 minus 150 is going to be my first calculation. All I've got to do is plug those in. So here we go. 525 minus 150, enter, and there's my 375. Then 94 minus 82, that one's an easier problem, 12. Your slope is the change in the y values divided by the change in the x values. So your slope is 375 divided by 12. If you divide 375 by 12, you get the simplified version, which is 31.25. So for every increase of 1 degree, we get 31.25 more visitors. Down here, that's about how much? 33 is the closest we get. Note that I used exact points, so I got a number that wasn't exactly what this problem was giving me. The reason that that occurred was because when we did our 94 degrees Fahrenheit and 525 visitors, we were using approximate numbers. So 31.25 would have been if these 2 points that we had used were exact. But in this problem, you notice they say the word about for each one. So if you're trying to figure out why there was that slight discrepancy there, that's why. Let's do our last question. Number 10. The graph below shows a line of best fit for the data collected on the amount of time students spent studying for their final exam and the scores they earned. There's your graph. We have the grade or percent on the y-axis, and we have time on the x-axis. The equation for the line of best fit is shown below. There's our equation. Based on the line of best fit, what grade should student expect if they studied for 4 hours? This one's easy. We just have to go to 4 hours and follow it up to where the line is. We see right here. We follow that over the y-axis. And what number is that? Well, this line represents 80. This line down here represents 60. So halfway between them would be 70. And this line crosses between the 70 and 80. So that's about 75%. So we go down there and we find 75%. And that's it. All right, so there's 10 problems. Work hard. Contact me and look up more if you have any questions.